Ready.
Good evening, everyone. I'm Hammad Majeed, and I shall present about the application of auxetic materials in the field of protective textiles. Before going into detail what are the auxetic textiles, we should clearly understand what actually happens when a bomb blasts. First of all, the blast wave from the explosion creates very highly compressed air particles that push into that spread into the surrounding environment, and any fragmentation of the bomb or any shrapnel included in the bomb, they are thrown outward at very high speed. The explosion creates fire and heat that may cause secondary explosions and heat. And immediately after the spread of shock wave, the cool air wave from the surrounding that start to target the actual where actual blast happens. You can see that buildings and any other material or any other object which is in the vicinity of the bomb explosion that can be pulled at very high speed. The main hazards of the bomb blast are primary fragments from the bomb that can move at the speed of 68 to 136 miles per hour, and the pressure of the blast wave is very high, and massive pressure can cause building damage, and you can see that only 15 pounds per square inch can rupture eardrums and cause permanent lung damage. In many instances reported in Afghanistan and Iraq war, that the people who have suffered from the bomb explosions in their close vicinities, that they may appear physically unharmed, however their brain had been damaged during the process. Secondary fragments include the shrapnel, rocks, glass, etc., and that may cause the heat and fire created by the explosion may cause secondary explosion. And higher pressure waves can even cause structural collapse. If you look at the anatomy of the blast event, generally it is expressed as trinitro-toluene load equivalent, which is used to express the power of the blast, and it is dependent on the type of explosives used, the standoff distance from the building or the target area, and the charge where charge has been put up, and the height of glazing if we have used glazed glasses to protect the indoors from the outside blast. Bomb blasts cause the collateral damage that include loss of life, damages to the property, and the destruction in the businesses. Generally, wherever a blast happens, the blast wave generally spreads throughout the street. It does not go into the atmosphere outside, and the streets act as channels to receive the blast wave, and areas wherever blast wave passes through, the glasses of the windows and the doors in the building may cause secondary damage. There is no such thing that could be used as blast-proof windows or doors. If we target to create or make truly blast-proof doors or the windows, those would be very heavy in weight, and existing building structures may not even withstand the pressure. And in addition, those windows and glasses and doors will not be see-through. University of Exeter has created some materials that could be used as blast mitigation purposes. As you can see in the picture, that Professor Evans of the University of Exeter is showing the Auxetic materials. It has been developed by collaboration of the University of Exeter, UK, and Engineering and Physical Sciences Council of the UK. Auxetic Technologies is a spin-off company of the University of Exeter. They have licensed its commercial rights to advanced fabric technologies used in textiles of USA. It has been primarily designed to be fixed over the inside of the windows, which are windows in the building which are potential terrorist targets, such as government offices and high-profile commercial properties. And glass curtains currently used consist of thick net curtain fabric, which are applied in conjunction with anti-shatter film applied over the glass of the window. The new curtain will remove the need of using anti-shatter films by using stronger, more resilient fibers woven into a carefully controlled textile structure. At just 1 to 2 millimeter thick, the new type of curtain will be designed to let in a reasonable amount of natural light, so thereby reducing the need of electricity for lighting purposes inside the building. It has got recognition over the world by winning Global Security Challenge European semi-finals in 2007 and 9, and Innovation Prize of Textiles 2007, Performance Textile Citation in 2008 for Innovation and Excellence. First, I will tell you what are auxetic textiles. Auxetic materials are found in nature, for example, in cat skin and bone from the human skin as well. To understand the concept of the auxetic textiles, consider the length of a bungee cord. If you stretch it out, it gets thinner. And if a piece of twine or some hard material is wrapped around the bungee cord, the cord effectively becomes thicker when the twine is drawn taut. That is the actually idea behind auxetic. The bundles of auxetic fiber wrap get thicker when stretched out. Such a fabric could be used in blast resistant purposes and in many different capacities. Here you can see that Dr. Patrick Cook, managing director of Auxetic Limited, is showing the basic materials made at the UK. Auxetic fabrics currently marketed by the brand Auxetic. These are auxetic materials that can increase in size on stretching, which are very high strength, absorb and disperse energy from explosions without breaking. High performance materials are combined with cheaper work components in a 1 to 100 ratio, and blast resistant properties of high performance materials are maintained. The only material on the market that automatically adjusts its strength and thickness in response to explosive force. It comprises of a series of auxetic yarns, each yarn wrapped using S or Z twist with a high strength power thread. Auxetic effect is determined by the precise angle at which the second fiber is bound around the first fiber and by the two fibers' relative stiffness and diameter. Yarns are then woven by left insertion across the bar by completely conventional processes. Off the loop, the wax becomes a tensile element in the fabric. When force is applied, the auxetic yarns deform, opening thousands of small pores in the fabric surface, and you can see the difference in these pictures. The elastomeric pore acts as the integral shock absorber. The pores allow high energy blast waves to weld through the material, significantly reducing the loads imposed on the fixture. Preliminary data are showing that curtains give a 25% reduction in impulse wave pressure. The spiral windings of high strength fibers catch any ballistic fragment, for example glass shards, caplets, reducing injuries and thus potentially saving lives. The fabric returns to its usual state when the stress is dissipated. Basic etc. fabrics have been tested with Honeywell, Spectra and DSM's Dyneema, wrapped around polyester monofilament and ballistic nylon. Strength of these materials can immediately be increased by probably 80 to 85% by substituting wet flan for ballistic nylon, which is actually nylon thickness. Currently, fibers under investigation are Kevlar, Vectran, Nomex, High-Press, steel, titanium, and carbon fiber. Important properties of the fibers which play an important role in the manufacture of these materials are elongation at break, breaking tenacity, initial modulus, density, LOI, thermal shrinkage, melting point, etc. As far as performance testing of the offsetting materials are concerned, initial tests conducted at UK are confidential and their data is not accessible. Advanced Fabric Technologies is currently working with independent testing labs for performance data. However, they have published that the single layer of extra fabric which stood shrapnel from a rocket propelled grenade detonation from a distance of 1.5 meters, and a single layer of extra fabric survived 8 consecutive grenade blasts from a distance of 1 meter. Potential applications areas are for use as glass curtains, for shrapnel protection within buildings, and for safety of the explosive ordnance disposal workers. The fabric thickness and strengthens as it is impacted by the glass, shrapnel, and other materials. Other areas include lighter compact vehicle armor that improves the performance of the military corpus, military personnel. Since it is a lightweight alternative for enhancing vehicle protection when employed in seats, interior lining, and glass shield systems. Other applications include military tents to protect against bombs, mortar, and grenade attacks during the battlefield, interwall glass sheeting for buildings in the commercial and sensitive areas, anti-spall lining for aircraft, ships, and land vehicles, shielding for mining operations, enhanced bulletproof vests and body armor. With that, I thank you all for your patience for listening.